Here we have another matrix algebra problem. In part A, we're given that A equals 2 times the inverse of A. We want to show that A squared equals 2I, where I is the identity matrix. Given the information in part A, we can answer part B. We want to simplify A minus I times A plus 3I. And we want to write that in the form RA plus SI, where R and S are real numbers. Here are some useful rules that we'll refer to in the question. So in part A, we have A equals 2 times the inverse of A, and we want to simplify that. So we post-multiply by A. So A times A will be A squared, and the inverse of A times A will give I, using rule number 1 over here. So that's basically finished. In part B, we're given that result from part A. So if A equals 2 times the inverse of A, then A squared equals 2I. We'll use that result to solve this problem. So we are given A minus I, and we multiply that to A plus 3I. Let's expand it. So we'll get A squared plus 3AI minus AI minus 3I squared. We can add the middle two terms. We'll get 3AI minus AI, which is 2AI. And we can simplify further. We have A times the identity matrix, which is equal to A, using the second rule here. And the identity matrix multiplied by itself will return itself, I, using the third rule down here. No matter how many times you multiply an identity matrix by itself, you'll always get the identity matrix. So from the question, we said that A squared equals 2I. So we've replaced the A squared with 2I. And that will give us 2A plus 2I minus 3I, which is minus I. And this is the required form in the question. Thanks for watching.